To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to continue with the extra questions related to electrochemistry. So in the previous chapter, we discussed some extra questions. Those were the MCQ type questions, multiple choice questions. So here I am going to discuss some essay questions. So these are the questions where you need to write the answers. So I am sure you will answer these questions first and then you will listen to my discussion. So extra question 2. Write few examples for equipment powered by electrochemical cells. Equipment that use electrochemical cells or batteries. What are the equipment? You can think of a clock, a wall clock, a wristwatch, a toy car, then even a torchlight. So like that, you all can write so many different equipments. A calculator. These are so many different electrical equipments that use electrochemical cells. So we will write a few of those. So here we can say clocks, clock, wristwatch, then calculators. As a common thing, I will say battery operated toys. So battery operated toys. Then there is the torch, light. Like this, you can think of many other electrical equipments. Even small radios that can be operated using electrochemical cells or batteries. The car batteries, the vehicle batteries. Vehicles use batteries. So we can write that as well. Vehicle batteries. Even computers, laptops, they also use batteries which we use to charge. Mobile phones, they also use batteries. So like this, you can write many electrical equipment. So write few examples for equipment powered by electrochemical cells. So in addition to this, I can even add mobile phones, and laptops. So here basically I have included almost all the equipments. Then the second question. What is the energy conversion taking place in an electrochemical cell? Now I have explained this to you all before also. There is a chemical reaction taking place that gives rise to the flow of electrons, therefore the flow of current. So basically electrochemical reaction gives rise to the generation of electricity. So what is the energy conversion? The chemical energy is converted to electrical energy. That is what you have to write here. Chemical energy is converted to electric energy. Chemical energy is converted to electric energy in an electrochemical cell. So then we'll move on to the next question. Extra question 3. The following activity is carried out to study the reactions occurring in electrochemical cells and the action of those cells. So to understand that, we'll look at the diagram. Here you can see there is a beaker containing dilute sulfuric acid, and inside that a zinc metal strip is placed. So here when you place the zinc metal strip, you have to make sure part of it is dipped inside the dilute acid solution and the other half of a part of it has to be above the solution so that it can be connected with conducting wires and all that when necessary. And also when that happens, you will understand or you will see the observations. What will you see here? Here, of course, you will see the zinc metal dissolving below this solution where it is in contact with the dilute sulfuric acid. You see the dissolving of the zinc metal strip, and also you will see gas bubbles liberated from the near the zinc metal. So those are the observations that you get when you do this activity. And you all know why that happens. Now zinc dissolves. Why? Because zinc metal loses electrons. The zinc solid loses electrons, forming zinc 2 plus ions. The zinc 2 plus ions go into the solution, leaving the electrons on the metal strip itself. So that is why the zinc strip dissolves. At the same time, when we say sulfuric acid, you all know the formula H2SO4. In this, there is H plus and SO4 2 minus. Now these H plus ions take up electrons from the zinc metal and they get reduced. They undergo reduction and become H2 gas. That is why we see the liberation of H2 gas there. So that happens when a zinc metal strip is dipped in a dilute sulfuric acid solution. And such a setup where you have only one metal in dilute sulfuric acid, we call it as an electrode. And you all know, students, when we connect two electrodes through an external conducting wire or a connecting wire, we can make the current to flow through that, and then it acts as an electrochemical cell. So here we are trying to understand what happens in an electrochemical cell and the action of the cell. So this is part of the cell. I'm sure you all can remember that. So based on all these information, we can answer the questions given here. A strip of zinc metal sheet is placed in dilute sulfuric acid contained in a beaker. That is what I explained to you. The first question, write 2 observations of this activity. What are the observations? Gas bubbles are liberated near the zinc strip. What is the other observation? Zinc strip dissolves. So, 2 observations. One thing, gas bubbles are liberated near the zinc strip and the zinc strip dissolves. So then we'll move on to the rest of the questions. Second one, write the process relevant to the observations you mentioned above using chemical symbols. So there, what do we write? The reactions. First I said gas bubbles are liberated. Then the other one, zinc strips dissolve. So I will start with the reaction relevant to zinc strip dissolving. How do you write that? There is a zinc solid. It becomes zinc 2 plus aqueous, losing 2 electrons. And you all know this is an oxidation reaction. When a species loses electrons, we call it an oxidation reaction. At the same time, H plus ions from the solution, that is acid, we need 2 H plus ions in order to balance the equation, take up 2 electrons, forming H2 gas. And that reaction is a reduction reaction. A species taking up electrons is a reduction reaction. So in these two, you can see zinc loses 2 electrons, 2 H plus ions take up 2 electrons. So the electrons lost by zinc are taken up by H plus ions. Always, when an oxidation occurs, there should be reduction also taking place. So this gives rise to the dissolving of zinc. The second one, liberation of hydrogen gas. So those are the reactions relevant to the observations we wrote before. Is that clear, student? So then, the next question. What is the name given to the reactions written above depicting the conversion of one chemical species into another, either by removing or accepting electrons? What is the first one? I will write the equation again and write whether it's reduction or oxidation. So, zinc solid becoming zinc 2 plus, losing 2 electrons, it is oxidation. The same way, H plus ions taking up 2 electrons, forming H2 gas is reduction. So like these students, even in this particular first reaction, you can say zinc strip dissolves and you can write the equation, liberation of hydrogen gas, and then you can write the equation. That is also okay. Then it will be more specific, more clear. And here I have written the equation zinc solid becoming zinc 2 plus by losing electrons is oxidation, and H plus aqueous taking up electrons becoming H2 gas is reduction. Then the fourth part. What is the name given to the setup in an electrochemical cell? What is the name given to the above setup in an electrochemical cell? Like I told you all, one metal dipped in sulfuric acid is one electrode. But for the current to flow and to have a complete circuit, we need 2 electrodes. That is how we get the 2 terminals of a battery. The positive terminal and the negative terminal. So, above is the electrode. Electrode. One electrode. So, here this is the function of a zinc electrode. When you have a zinc electrode with another electrode, for example, it can be copper electrode or iron electrode, connected by an external connecting wire, there will be electron flow through the connecting wires. Therefore, there will be current flow through the connecting wires. Then it becomes an electrochemical cell with 2 terminals, the positive and the negative terminals. So, with that, students, I'll move on to the next slide. Extra question 4. Consider the following cell constructed using iron and copper metals. So, here, students, you all have to look at the metals. It is iron and copper metals. So, in the cell also, you all can see it is an electrochemical cell where they have dipped iron and copper in dilute sulfuric acid. So, you all know there will be chemical changes taking place and that will make the electricity to flow through the cell. So, here from the position of the 2 electrodes, you all know which is more reactive. Iron is more reactive than copper. That is why we usually write iron on this side and copper on the other side. More reactive one on the left side, less reactive metal on the right side. So, thereafter you all know at the iron strip, there will be oxidation taking place. Iron strip will dissolve, forming Fe2 plus ions, losing electrons. So, that is oxidation and therefore, iron strip acts as the anode and it becomes the negative terminal of the cell. At the same time, near the copper strip, because of dilute sulfuric acid, dissociation of dilute sulfuric acid gives rise to H plus and SO4 2 minus ions. Those H plus ions will take up electrons from the copper strip and get reduced. So, because reduction occurs, copper strip becomes the cathode. And because H plus ions take up electrons from the copper strip, it becomes positively charged. So, here iron strip negatively charged and it is the anode. And copper strip is positively charged and is the cathode. So, these are the things you all have to remember in relation to this electrochemical cell. So, iron and copper as the electrodes. Now, if we look at the questions given to us. what is the name given to the zinc and iron metals in the above cell? So they are known as the electrodes, where the oxidation and reduction occur and they become the positive and negative terminals of the battery. So they are the electrodes. Then the second one, write the half ionic equations for the reactions taking place in the above cell. What are the half ionic equations? Now I told you all the iron strip dissolves. So that means Fe solid becomes Fe2 plus aqueous by losing 2 electrons. And that is the oxidation reaction. So therefore it becomes the anode. But we don't have to write that here. Only the half ionic equation. Then near the copper electrode, what happens? 2 H plus ions. Now we need to write 2 because we need to balance the number of electrons and the charges. And it should be a balanced half ionic equation. Take up 2 electrons, giving rise to H2 gas. Now you can see this is a balanced half ionic equation. 2 hydrogen ions and 2 hydrogen atoms there. So 2H plus 2 electrons giving H2 gas. And this is a reduction reaction. And that occurs at the cathode. And here cathode becomes the positive terminal. All that I explained there, but here we only need to write the half ionic equations. Is that clear, students? So then, what is the name given to reaction in which a species loses electrons? So that is this iron loses electrons forming Fe2 plus aqueous. So there, that is an oxidation reaction. We can write it as oxidation, or you can say oxidation reaction. This term is optional. You can just write oxidation or you can write it as oxidation reaction. Is that clear, students? So then I will move on to the next part of this question. Fourth one. What is the name given to the reaction when a species gains electrons? What is that? 2 H plus ions taking up 2 electrons forming H2 gas. That is reduction reaction. Reduction reaction. Reduction reaction. Here we can just write as reduction or reduction reaction. Either way is fine. Then the fifth one. What is the name given to the electrode where oxidation takes place? What do we call that? That is known as the anode. Oxidation takes place at the anode. And then, what is the name given to the electrode where reduction takes place? What is that? That is the cathode. That is the cathode. What is the name given to the electrode where oxidation takes place? It is anode. And the electrode where reduction takes place, it is the cathode. I am sure you all can understand that. So then we'll move on to the next slide. Identify the following electrodes in the cell. So what is the anode there? Now you can see, you can remember I explained to you all the iron strip undergoes oxidation. So oxidation occurs at the anode. So what is the anode? It is the iron strip. Iron strip, or we can write it as iron strip. Then what is the cathode? Cathode is where the reduction takes place. So near the copper strip only the reduction takes place. So copper strip is the cathode. Strip is the cathode. Then, if we are to identify the next one, part 8, identify the following electrodes in the cell. Positive electrode and negative electrode. Now, when oxidation occurs at the iron strip, what happens? Iron becomes Fe2 plus, losing electrons, and the Fe2 plus ions go into the solution. So, what remains in the iron strip? the electrons remain in the ion strip. Because of that, the ion strip becomes the negative electrode, and here the electrons can flow through the negative electrode to the copper strip. At the same time, when we have H2SO4, the H plus ions come closer to the copper strip. They take up electrons from copper and they get reduced. Because of that, the copper strip becomes the positive electrode. So you can remember that copper strip is the positive electrode, whereas the iron strip is the negative electrode. You can remember that, students. So there. Positive electrode is copper and negative electrode is iron. And write equations for the reactions taking place at the anode and cathode. What is the anodic reaction? That is where the iron strip dissolves. So anodic reaction, Fe solid, we have written this reaction before also, becomes Fe2 plus aqueous, losing 2 electrons. And the cathodic reaction, what happens there? Near the copper strip, 2 H plus ions, H plus aqueous, takes up 2 electrons, forming H2 gas. That is the cathodic reaction. So these are the answers, students. Here you all have to remember these are extra questions where we are trying to recall and understand and revise what we have discussed in the lesson. So all these give you an understanding about the functioning of an electrochemical cell. Anode is the iron strip where oxidation takes place. Cathode is the copper strip where reduction occurs. And the copper strip becomes the positive electrode because electrons are taken from it. And iron is the negative electrode because when iron Fe gets oxidized here, the electrons are left on the iron strip itself. So because of that, it becomes negatively charged. The anodic reaction is Fe solid becoming Fe2 plus aqueous, losing 2 electrons. And the cathodic reaction, 2H plus aqueous plus 2 electrons giving rise to H2 gas. So I am sure, students, you all also have answered these questions correctly. So with that, I will move on to the next slide. Extra question 5. Consider the following cell constructed using iron and zinc electrodes. Fill in the following table. So here you have both iron and zinc. So you all know, students, when we look at the electrodes in an electrochemical cell, you should know which metal is more reactive in order to identify the anode and cathode. So when you take zinc strip and iron strip from the activity series, you all know, students, zinc is more reactive than iron. Reactivity or activity of metals, reactivity, zinc is more reactive than iron. And from the electrochemical cell itself, from the side of the metal strip, you can identify which becomes the anode, which is the cathode, or which is more reactive and less reactive. Usually, more reactive metal is written on the left side, less reactive metal on the right side. So that is something you all know. So since zinc is more reactive, what happens there? Zinc loses electrons and becomes zinc 2 plus. So it gets oxidized and the electrons remain on the metal strip. Therefore, zinc becomes the negative electrode, and since it is the oxidation, it is the anode. At the same time, H plus ions from sulfuric acid take up electrons and become H2 gas near the iron strip. So because of that, iron strip loses electrons and becomes the positive electrode. And since this is the reduction reaction, iron becomes the cathode. So those are the changes taking place or the reactions taking place in this particular electrochemical cell. So since zinc is the negative electrode, electrons flow from zinc to iron, and at the same time from iron to zinc, it is the flow of conventional current. So those are the things you have to know related to this electrochemical cell. If we fill the table, that is the question. Electrolyte solution. What is the electrolyte solution given there? Dilute sulfuric acid. Dilute sulfuric acid. Sulfuric acid. You know the chemical formula H2SO4 aqueous. You can just write dilute sulfuric acid. Just to give you all more information, I have written the chemical formula also. What is the anode there? It is the zinc strip. Then what is the cathode? It is the iron strip. Iron, or we can say Fe strip. So here also, instead of zinc, you can write it as zinc, Z-I-N-C. Then what is the positive electrode? It is the iron strip. Fe is the positive electrode. And the negative electrode is zinc. An anodic half reaction or the oxidation half reaction is this one. Zinc solid becoming zinc 2 plus aqueous, losing 2 electrons. Now here, of course, I have not written the physical states because I just wanted to explain what is happening. But when you are writing the anodic half reaction or the oxidation half reaction, you have to make sure it is balanced, and also you have to give the physical states. Then cathodic half reaction, that is this one. 2H plus aqueous, taking up electrons, 2 electrons, giving rise to H2 gas. So that is the cathodic half reaction or the reduction half reaction. Because you all know oxidation occurs at the anode, reduction occurs at the cathode. So these are the information related to the electrochemical cell there. So if we look at the cell and the answers, electrolyte solution is dilute sulfuric acid or H2SO4 aqueous. Anode is the zinc strip or Zn strip. Cathode is the iron strip, Fe strip. And positive electrode is iron, Fe. Negative electrode is zinc, Zn. Here also you all can write this as iron and zinc. Either way is fine, students. You all can use the symbols or you can write the words to answer these questions. But for reactions, you have to use the balanced equation using symbols. Anodic half reaction, zinc solid becoming Zn2 plus aqueous, losing 2 electrons. Cathodic half reaction, 2H plus aqueous plus 2 electrons, giving rise to H2 gas. So that is this particular electrochemical cell with iron and zinc as the electrodes. I am sure you have answered those correctly. Then we'll move on to the next question. Extra question 6. Label the parts of the electrochemical cell constructed using zinc and copper electrodes. So here it is zinc and copper electrodes given below. Indicate the direction of current flow and electron flow in the diagram. So when you are given zinc and copper, first you have to consider the reactivity of the metals. Which is more reactive? Zinc is more reactive than copper. So zinc has to be on this side, the left side. So this is the zinc strip. Then on this side, we will have the copper strip. So here, of course, students, there is another advantage for you all. The electrodes are colored. So from the color, you all know zinc has a normally grayish color or silvery color metal, whereas copper is a brownish color metal. So from that also you can identify. But if they just give you the lines in black color, if the diagram is in black and white only, then of course you should know usually the more reactive metal is on this side. That is the electrode on this side. So then we need to identify the positive and negative electrodes. Zinc strip, since it's more reactive, undergoes oxidation. So that is the anode. And when oxidation occurs, the ions go into the solution, electrons remain on the zinc metal. Because of that, this becomes the negative electrode. At the same time, there is dilute H2SO4 here, sulfuric acid, so it dissociates to give H plus ions and SO4 2 minus ions. The H plus ions go near that are near the copper strip, take up electrons from the copper strip and they get reduced. So therefore, copper is the cathode where reduction occurs, and because electrons are taken from the copper strip becomes positively charged. So zinc is the anode and the negative terminal. Copper is the cathode and it is the positive terminal of this electrochemical cell. So then, we have labeled the diagram. We need to indicate the direction of the current flow also. So in order to indicate the direction of current flow and electrons flow from negative to positive charge. So this is the electron flow. And this direction is the current flow. Conventional current flows from positive to negative terminal. Copper to zinc is the current flow. Zinc to copper is the electron flow. So then we look at the next question. Write the half reactions occurring in the cell. Half reactions. So the zinc strip. What happens at the zinc strip? Zinc dissolves. Zinc solid loses electrons, forming zinc 2 plus ions. That is the oxidation reaction. So therefore, zinc becomes the anode. And near the copper strip, what happens there? The H plus ions. 2H plus aqueous take up electrons, forming H2 gas. 2H plus aqueous take up 2 electrons, forming H2 gas. So those are the half reactions occurring in the cell. They have not asked us to write what is the oxidation and what is the reduction, or what is the anodic reaction and what is the cathodic reaction. So we do not need to write that. We only need to write the half reactions. Even we don't have to specify these where it occurs. Only the half reactions are more than enough. So then I'll move on to the next slide. Extra question 7. Some liquids and solutions conduct electricity while some don't. So you all know the liquids and solutions that conduct electricity, we call them as the electrolytes. And the liquids and solutions that do not conduct electricity, we call them as the non-electrolytes. So you are familiar with that. The first question. What is the name given to the liquids and solutions that conduct electricity? What I just said, electrolytes. Electrolytes. Electrolytes or electrolyte solution. Write 2 examples for the type of liquids or solutions mentioned in part 1 above. Now, electrolytes, you all know ionic compounds like sodium chloride. In the solid state, they don't conduct electricity. Why? Because there are no mobile ions. But in the liquid state, fused or molten state, which is the liquid state, or the solution state, when they dissolve in water, in those instances, there are mobile ions. So because of that, they conduct electricity. So solutions or liquids of ionic compounds conduct electricity. Then we have the acids. Dilute sulfuric acid, dilute hydrochloric acid, They dissociate completely, so there are mobile ions. Acids conduct electricity. Then there are bases. NaOH aqueous, NaOH solution where it dissociates into Na plus and OH minus. Bases also conduct electricity. Salt solutions. Even the ionic compounds like sodium chloride is a salt. So salts, when they dissolve, they also dissociate to form the positive and negative ions. They also conduct electricity. So in all these, there are mobile ions and they conduct electricity. So here we are supposed to write 2 examples for the type of liquids or solutions mentioned in part 1 above. Now, in addition to these, students, you all know acidulated water. Now, water is a covalent compound. It does not conduct electricity normally. It is a non-electrolyte. But when you add a little amount of dilute sulfuric acid to them, due to the presence of sulfuric acid, there are mobile ions in the acidulated water. Because of that, it becomes an electrolyte. It conducts electricity. So that also can be written as an example. So here I will say fused sodium chloride. Sodium chloride. Here also we can use symbols or write it in words. And acidulated water. Acidulated water or acidified water. They are both electrolytes. Then we'll look at the next question. What is the name given to liquids and solutions that do not conduct electricity? They are non-electrolytes. Non-electrolytes. Write 2 examples for the type of liquids or solutions mentioned in part 3 above. Non-electrolytes, like I told you all, distilled water, pure water, does not conduct electricity. Then there are the different covalent compounds which are liquids like kerosene, diesel, petrol, glucose solution. They don't have mobile ions. So because of that, they also don't conduct electricity. So you can write any 2 examples. I will write distilled water and kerosene. You can also write glucose solution, diesel, petrol, anything that can be written here. And remember, students, similar to acidulated water, even the tap water, sea water, which have salts dissolved in it, they also can conduct electricity. So they also come under electrolytes. Only distilled water does not conduct electricity. Pure water, distilled water is covalent. So it doesn't conduct electricity. But water that has ions present in it, it conducts electricity. You have to keep that in mind. So with that, students, I'll move on to the next question. Extra question 8. An activity carried out to identify liquids and solutions that conduct electricity is shown below. Distilled water and acidulated water were used as the liquid and solution. So here, look at the substances. Liquid water, distilled water and acidulated water were used as the liquid and solution. Distilled water, the liquid, acidulated water is a solution. A deflection was observed in the ammeter only when acidulated water was used in the above setup. I just discussed this with you all in the previous question also. You all know distilled water is a covalent compound. So there are no mobile ions. Because of that, it does not conduct electricity. Whereas acidulated water, due to the presence of dilute sulfuric acid, there are mobile ions in the mixture. So because of that, acidulated water is an electrolyte. It conducts electricity. So distilled water is a non-electrolyte. Acidulated water is an electrolyte. So this is the setup. You can see the cell here, the container or the beaker containing the liquid or the solution. Inside that we use 2 carbon electrodes and they are connected to the dry cell, the batteries, positive and negative terminals, and there is the ammeter. So the batteries provide electricity that is used to observe whether they conduct electricity or not, and then from the deflection of the ammeter you can confirm that. So that is the observation there. So what can you conclude from the deflection of the ammeter? If it deflects, the solution or the liquid conducts electricity. So we can say deflection of the ammeter confirms that the liquid or solution conducts electricity, that it is an electrolyte. So that is what you can conclude from the deflection of the ammeter. The solution or the liquid conducts electricity, so therefore it is an electrolyte. Then I'll move on to the next question. Second one, based on the observation, what are the terms used to identify distilled water and acidulated water? That I told you all, distilled water, water is a non-electrolyte. Non-electrolyte, and acidulated water, water is an electrolyte. Then, the third question. Why does acidulated water conduct electricity and distilled water does not conduct electricity? I explained this to you all. Distilled water, water is a covalent compound that does not have any mobile ions. That is why it does not conduct electricity. Then we can say when an acid so here within brackets I have written H2SO4 because that is what we normally add. When an acid is added to distilled water, that dissociates. Therefore, there will be mobile ions and acidulated water conducts electricity. You all know that also, students. Even at 25 degrees Celsius, water also dissociates to a certain extent. but the number of H plus and OH minus ions are not enough to conduct electricity. So there in the solution, the acid dissociates to give rise to H plus and OH sulfate ions. So therefore, there are mobile ions and that makes the charges to flow. So you all can understand that. So distilled water is a covalent compound that does not have any mobile ions. That is why it does not conduct electricity. When an acid, that is H2SO4, is added to distilled water, that dissociates. Therefore, there will be mobile ions and acid-related water conducts electricity. I am sure you all also can give a similar explanation. So with that, students, I will move on to the next slide. Extra question 9. Answer the questions based on the cell given below. So look at the question here, the cell given below. There is a source of electricity. So you all know it has to be an electrolytic cell. When we supply electricity, it will be an electrolytic cell. And here you can see carbon electrode P, carbon electrode Q. And the electrodes are connected using a connecting wire and there is an ammeter. So that is to measure the electricity or current flowing through the circuit. And we have a liquid or a solution. So by supplying electricity, we will make an electrolytic reaction to occur, a chemical reaction to occur. So with the two carbon electrodes. Now if we look at the question, what is the name given to the above cell? So like I said, it is an electrolytic cell. So it is an electrolytic cell. Lytic cell. Then, what is the name given to the liquid or solution X if there is a deflection in the ammeter? If there is a deflection, that means current is flowing through the liquid. That will be an electrolyte solution. Electrolyte solution. What we discussed in the previous question also. Electrolyte solution, or we can just say electrolyte. Then, we can leave out this term. We can just call it as electrolyte. What is the name given to the liquid or solution X if there is no deflection in the ammeter? Then it will be a non-electrolyte. Non-electrolyte. This is also a question similar to the previous one. Here it is given as an activity. So then I'll move on to the next slide. Fourth one, write another material that can be used as electrodes instead of carbon. Now here we use carbon. Carbon is an inert electrode. Carbon graphite is an inert electrode because it doesn't undergo any change during the electrolytic process. Similar to that, we can use platinum as the inert electrode. So that is the other material. We can use platinum. Inert electrodes. Then the fifth one, identify the positive and negative electrodes in the above cell. Now in an electrolytic cell, depending on how we connect the positive and negative terminals of the battery, here positive terminal is connected to electrode P. So electrode P becomes the positive terminal of this electrolytic cell, the positive electrode. And Q is the negative electrode. So identify the positive and negative electrodes in the above cell. Electrode P. Electrode P is the positive electrode. Electrode Q. Q negative electrode. Electrode P is positive and electrode Q is negative. So we have identified the electrodes. Then I'll move on to the next slide. Where does oxidation take place? Why? Now here we already know P is the positive electrode, Q is the negative electrode. Now in the solution X also we will have two ions, let's say A positive and B negative. So the negative ions migrate towards the positive electrode. Positive ions migrate towards the negative electrode. And the negative ions, they lose electrons at the positive electrode and they undergo oxidation. Because of that, the positive electrode is the anode. Oxidation, therefore it is the anode. And here it will be reduction and that will be the cathode. You all can remember that. So where does oxidation take place? Why? So there we have to say at electrode P. Where does oxidation takes place? Electrode P. Electrode P. Why? Negative ions get oxidized at the positive electrode. And then, where does reduction take place? Why? Reduction occurs at the negative electrode. Why? The positive ions migrate towards the negative electrode. So that is electrode Q. Why? The positive ions get reduced at the negative electrode. So then, in this particular cell, what will be the anode? What will be the anode? Anode is electrode P. And what will be the cathode? That is electrode Q. Electrode Q. That is how this particular cell functions, an electrolytic cell. Electrode P is where oxidation takes place, that is the anode. Electrode Q is where the reduction takes place, that is the cathode. And that is what we have answered here. So with that, I'll move on to the next slide. So the part 10, what is the purpose of using carbon as the electrodes? Why do we use carbon? I told you all this before also. Carbon is an inert electrode. An electrode that does not undergo any changes during the electrolysis process. So here, because carbon, that is graphite, is an inert electrode that does not react during the electrolysis process. Very important, you have to say it doesn't react or it doesn't undergo any changes during the process because it is an inert electrode. That is the important answer. Then, so the part 11, what is electrolysis? Now you all can remember in an electrolysis process, we supply current through a solution or a liquid that can conduct electricity. That is why it is an electrolyte solution. That is an electrolytic process. At the same time, by supplying electricity, we make a non-spontaneous reaction to take place. So that is also electrolysis. Both are referred to electrolysis or electrolytic process. So it is better that we write both of them together. So here we can say supply electricity through a liquid or solution that conducts electricity to bring about a chemical change that is usually a non-spontaneous reaction is known as electrolysis. Supply electricity through a liquid or solution that conducts electricity to bring about a chemical change that is usually a non-spontaneous reaction is known as electrolysis. So both these definitions, the explanations are given in your textbook in two separate places, but both of them refer to the electrolysis process. So I have combined the two and written one explanation. Supply electricity through a liquid or solution that conducts electricity to bring about a chemical change that is usually a non-spontaneous reaction is known as electrolysis. When you say non-spontaneous reaction, you all can remember, students, I have explained this. When we have fused sodium chloride, normally it does not divide to give sodium liquid and chlorine gas. That is what is known as a non-spontaneous reaction. But by supplying electricity, we can do that. That is how we extract sodium. So that is the process of electrolysis. So students, that is the answer for this question. And I am sure up to now you all were able to understand and answer the questions correctly. So with that, students, I am going to end this chapter. And in the next chapter also, I will discuss some more extra questions with you all.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.